Good morning, everyone. I'm Dr. Priyanka. Today I'm here to discuss scientific methods. Scientific methods, basically methods while conducting business research. How do we do research? Generally through scientific method. If we are not doing research properly through scientific method, then that means we might get some errors in the last. We generally get errors in the last when we try to do work through uh, some jugaad and something like that, right? So this is the same. If we go with scientific methods, then we definitely get results, whatever they are. I mean, of course, when you start doing research, it's not like that you should always get positive results, you should always get negative results. Sometimes we get neutral results as well. They are natural results, right? So it's just that results, whatever results you'll be getting, if you are going through scientific methods, then they will be correct at least. So let us start with what actually scientific method is. The use of a set of prescribed procedures for establishing and connecting theoretical statements about events, for analyzing empirical evidences, and for predicting events yet unknown. We are talking about theory as well as empirical evidences here. Or very famous definition here is the analysis and interpretation of empirical evidences, facts from observation or experimentation to confirm or disprove prior conceptions. Basically, there is no consensus concerning about exact procedure for the scientific method, but most discussions generally lead to telling us that it is empirical testability. Basically, empirical means we had a discussion about empirical in our last topic, and empirical means numbers. Numbers can be through someone's behavior, some experiment, or anything. Like, for example, you want to know average age of students of class 10th, then what will you do? You'll be collecting the data of age of all the students, and then you'll average that out. That is also a kind of empirical evidence of age, average age of class 10 students. So that is how we are going to check scientific methods. There is a set procedure when we say that we are talking about scientific method. That means there will be a set procedure, there will be a process to follow, so as to reach the goal. But before starting with the process, before going through the steps, we'll have a look at two three words which we'll be using in actual steps. And here these are. Proposition. You must have heard of this particular word, proposition, before, or at abstract level. What is it? When we are talking about abstract level, we are basically talking about theories. And when we talk about empirical level, we are talking about numbers, right? So when we say that, we generally say, if you do this daily, you'll get habitual of it. You'll get it as a good habit. Generally we say that if you run daily for 10 kilometers, you might be able to run faster one day, right? We generally tell people, you start following it for 10 days, then 11th day you'll automatically do it. That is what reinforcement is. Reinforcement means trying to do something for betterment daily so that it becomes a habit. Concept A to concept B, right? The same way it is about statements or proposition. Proposition basically is a statement at abstract level, at theory level. But when we talk about the same thing at empirical level, that means we are talking about numbers, then we call it as a hypothesis. For example, I want to increase sales, so what will I do? For that, there is an example: dollar bonus for sale volume over quota. That means always makes 4 sales calls a day. For example, if I need to improve sales, I will make more calls so as to increase the sales, right? When I talk about things, about statements, general propositions at abstract level, I generally talk about simple things. I talk about the theory. Like we generally talk about this in our daily life. If you do this today, if you start doing it one day, it will not be hard for you to do this, right? The same way, when it comes to empirical level, we say that if you want to improve this, if you want to do this, you have to do this. And we talk about numbers. And if you want to increase sales by 1%, then you need to make 4 calls daily, so that you can improve it by 1% up to 30 years or up to 30 days, right? I mean, when we talk about abstract level, we just talk theory, but at empirical level, you need numbers to talk about that. Abstract level is basically it's about concept, it's reality, propositions. We just talked about propositions. These are statements concerned with the relationships among concepts. For example, we generally say at this age, baby's height should be this. At this age, your height should be this. We generally talk about such things. These are statements or say relationship among two concepts, age and height, right? And at empirical level, we talk about the same thing, but we'll be talking in numbers. A hypothesis is a proposition that is empirically testable. It is an empirical statement concerned with the relationship among variables. We are talking about variables here, like I just mentioned, age and height. A variable is anything that may assume different numerical values, right? For example, class 10 students, age should be around 15, 16 or 17. So that is number, and age is variable. And suppose we talk about their scores or something in their 10th class, and we can relate that with age, because the student is just 15 years, that is why his mind is sharp or something like that, we can say. And because students is 17 or 18 years or 19 years, he might have failed in some classes, so his mind is not sharp. We can assume such things, but for everything, when we are talking about empirical level, we need numbers. Now let's talk about the actual method in scientific theory. First step is assess relevant existing knowledge. Second is formulate concepts and propositions. Then statement of hypothesis, design research, acquire empirical data, analyze and evaluate data, provide explanation, or basically state the new problem. Let us discuss them one by one. Assess relevant existing knowledge. How would you assess existing knowledge? How would you know where to get that particular knowledge? For example, you want to work on CSR. For example, you want to check existing things on CSR. What will you do? You will start Googling it. You will start searching about the same thing over and over the internet, over the libraries, through newspapers, magazines, maybe some research papers, some books. There are so many things from where you can assess relevant existing knowledge on anything today. It's very easy these days. So assessment of relevant existing knowledge. And why we have to do this? Because if we'll be generating our own knowledge, for that we should know what what data, what information exactly is already available in the market. You can read reports, some institutional books, or maybe some data available anywhere. And this can be observational data as well. Maybe someone else has collected some data for the same but similar kind of project. You can go through that particular data as well. These days, big data is available. Experimental data can be used. Survey responses, if they are available with someone, they can be used. Or you can even do your own survey at very small scale, or maybe at larger scale as well. Some passive data collected for some other experiment. So these are the sources to collect or to assess existing knowledge or existing data, so as to increase your own knowledge. Second is formulate concepts and propositions. What do we mean by concepts and propositions? Concepts basically is if you want to analyze age and height of a child, then you need to read everything related to age and height of a child, so that you can come to the term that yes, these might be the factors which might affect height of a baby, or these are the factors which might not affect the height of the baby. There are so many things. The age is not the only criteria to judge height of a, to check, to tell height of a child. So that is why we need to check concepts and propositions already available in the field about the same topic. For example, we are talking about CSR. So you need to check every concept and proposition, everything available regarding that, so that you know how it is taken care of, how people take CSR as. Then statement of hypothesis. When you state something, when you say that I want to check this and that, whenever there's a hypothesis, we always try to link something. There are two kind of hypothesis. One is null hypothesis, another one is alternate. Null means zero, no hypothesis at all, sort of no relation at all, no association, no relationship, no effect. And alternate is opposite, whether there's a positive effect or negative effect, whatever you want to say. So for example, there is a link between trial and purchase. We go to malls, we try different clothes, and whether we purchase that or not, that depends on trial. How many trials did you have, how many purchases did you go for, right? Or maybe there's a link between market share and market penetration. So there are so many examples, but when you want to actually state hypothesis, you will always write it like there is no link between trial and purchase. And alternate hypothesis would be there is a positive link or negative link between trial purchase. It depends on which kind of studies you have gone through, what kind of observations you have already seen. So this is how we'll be stating the hypothesis. And one important thing is whenever we are going to state any kind of hypothesis, we already know something about it, because like I was saying that there is a link between trial and purchase. So you must be knowing some theory behind it. You must be knowing something, at least something about it. That is how you will be going to state hypothesis. That is why we are already assessing the existing information data, and then form already available concepts and propositions about the same thing, about the same topic, so that we can actually state hypothesis in a well-defined way. And then we have to take care of this, that results of the testing are confined to the situation it was tested in. For example, you have taken just 2 malls to check something, to check this particular thing, trial and purchase. So you will be able to, you will not be able to generalize that all over India or all over the country, all over the city. So whenever you are stating any kind of hypothesis, keep this thing in mind, that your sample should also be good. Then design of research design. This is very important step, but we reach to this step after assessing already available information about the same topic. And when you design research, at that time you exactly know what you want to search about. You should know. And in this design research, we'll be stating almost everything: what kind of the data we'll be needing, which kind of the tools we'll be using to collect the data and then analyze the data, what kind of the information you are looking for, and what kind of information you want to generate. You'll be having slight idea about that also, but of course results would be results. Then acquire empirical data. At the time of research design, we did everything. We actually formulated the whole study in one or the other way. Now we know what is to be done. When we generally say research, if you have designed the research beautifully, then half of the work is done. So now just mechanical work is left. Acquire empirical data. How would you do that? That is generally decided at the time of research design. You can collect data through surveys, through questionnaires, by talking to people on phone, or by mailing them the list of questions, or maybe through some annual reports, some reports available in the market. There are so many things these days. Data is available like anything. If you want some data, I don't I mean for the purpose of research, for example, you need some companies data, companies profits for over 100 years, for over 10 years, or maybe you need data of 1000 or 1 lakh companies for 10 years. These data are actually freely available these days. You can go to different databases and collect the data in just one click. Initially it was not easy, but these days you can collect data in 1 or 2 hours for your whole project work. So acquiring empirical data is actually very important, and it's like you should just know how many databases are available so that you can collect the data easily. Then analyze and evaluate data. This is very important step now, because when you have collected the data, now the thing is, how will you be analyzing it? See, suppose I'm just checking what is the average age, or what is the average height, or what are the average students passed in 10th class. So I what kind of data I'll be needing? Age of all the students of 10th class, or height of all the students of 10th class, or marks, passing marks, or pass or fail, whatever that is, or maybe marks collected by the students of class 10, right? On that basis I'll be collecting their average and my work will be done. This is so simple. But for that I should know what kind of the results I'm looking for, what kind of the data I need. So analyze and evaluate data means you will be analyzing the data, empirical data you have collected through some tools. For example, there are so many tools available. For example, average. For average, you can simply do sum up all the ages and divide by number of students, right? The same way, there are so many tools available: t-test, z-test, correlation, regression, factor analysis. So many tools are available these days, and these are also like you don't have to actually put the formula in it. There are softwares available, and you just need to put your data in the software and it will analyze. It will give you the data in the form of table. Now you need to evaluate that, whether this is whether the variables are positively related, whether they are even related or not, neutral, no relation, positive, negative relation, whatever this is, right? So now you need to check the evaluation basically on the basis of that tools, history, and everything. That is really very important, because on that basis you will be making a report. Now last step is provide explanation, state new problem. You will be providing explanation why this result happened this way, because when you when you started with step 1, assess relevant existing knowledge, at that time you knew nothing about the topic. But when you reached analyze and evaluate data, you know a lot about that. You have data as well, you have met people, you have collected data through libraries, so many things have happened. So now you are actually knowledgeable about the data, and you will be providing explanation accordingly as per the results. And now you'll be checking whether there is a problem or not. You'll be checking with the limitations. Maybe if you just for example, if you wanted to know about that trial and purchase thing only, and you have you know that there are 50 shopping malls in the area you have selected, and you just went to 10 shopping malls, and those 10 were same, and you left some 10-15 malls of some different kind of environment, some different kind of crowd coming there. So it would not be able to generalize the statement. So you can state that in your limitation, that you could not go for that particular thing, because research is never complete. Research is an ongoing process. You can never say that you have completely analyzed it. By the time you reach the last step, you realize that so many things were there which could be done, right? So these things would be your limitation. Now scientific methods also have, see, when we talk about scientific methods, these are really good. They have some positive sides as well as some negative sides. What might be the positive side of this? We'll be going through that particular thing with the help of an example. Zen and the art of motorcycle maintenance. What is it? What do you think? Is it really very hard to maintain a motorcycle? When you actually maintain a motorcycle, it is not very hard, and you don't actually need a scientific method for that. But it is just generally said that it takes twice as long, or maybe 5 times as long, or maybe a dozen times as long as informal mechanical technique. But it is really helpful when you have done everything possible for your motorcycle and nothing is working, then you can go through scientific method, and believe me, it's done. Whenever we are trying some methods just like that and things doesn't happen, then you can go through scientific methods and you'll really get some result. But this actually holds some limitations as well. What might be the limitations of scientific method? Because scientific method would also be applied by a human being, right? So it's not like that we are going we'll be able to actually apply the method 100%. So due to some human complexities, there are some limitations. Then moral or ethical problem, how morally we have conducted the scientific research, that is also one of the things. Then measurement problems, different aspects of human behavior are psychological in nature and which cannot be actually measured. When we talk about human behavior, that is not actually measured 100% properly. Then some external variable control problems are also there. Scientific studies conducted on humans may have limitation of weak or no control over the situation. And sometimes when I am conducting a study over humans, then I am also a human being who is conducting a study, and the subject on which study is conducted is also human being. So there comes a connection between two people, and that also creates some problems. So there are so many problems with even with scientific method, but these are not so much. These can be overcome with little things, with some changes we can take care of. Now we're done with this self-assessment questions. List the steps involved in the application of the scientific method. I hope everyone would be able to do that, because we have just listed down the steps of scientific method, and these are assessment of relevant existing knowledge of a phenomena, formulation of concepts and propositions, statement of hypothesis, design of research to test the hypothesis, then acquisition of meaningful empirical data. Sixth is analysis and evaluation of data. Seventh is proposal of an explanation of the phenomena and statement of new problems raised by the research, right? Then second question, how does a hypothesis differ from a proposition? Though I have mentioned the same thing in the PPT, but still, propositions are statements explaining the logical linkage among certain concepts by asserting a universal connection between concepts, whereas a hypothesis is a formal statement of an unproven proposition that would be empirically tested. Now some true false. Number one, the scientific method is a set of prescribed procedures for establishing and connecting theoretical statements about events, for analyzing empirical evidence, and for predicting events yet unknown. If you don't know whether it's true or false, read it again and then answer calmly. But this is true. The basic of scientific business researcher operates at two levels: on the abstract level of concepts, hypothesis, and on the empirical level of variable propositions. Sometimes we don't notice it 100%, but try to notice it. Abstract level of concepts means propositions, and empirical level of variables means hypothesis. So this is opposite. So that means it is false. Then next, in most scientific situations, there are alternative theories to explain certain phenomena. Yes, there are available. So it's a true. The first step in the scientific method is to formulate concepts and propositions. Is it true or false? It's false, because this is actually the second step. Whereas first step is assessment of relevant existing knowledge of a phenomenon. Now multiple choice questions. You'll get these answers in the PPT. Which of the following is a step involved in the application of the scientific method? A. Statement of hypothesis. B. Formulation of concepts and proposition. C. Analysis and evaluation of data. D. All of the above. Now read it carefully. Statement of hypothesis, yes, this is a step. Formulation of concepts of propositions, yes, this is also involved. Analysis and evaluation of data, yes, this is also involved. That means all of the above is answered. What is the last step in the application of scientific method? And the answers are assessment of relevant existing knowledge of a phenomena, then proposal of an explanation of the phenomena and statement of new problems raised by the research, yes. Design of research to test the hypothesis, acquisition of meaningful empirical data. It's very clear that it is proposal of an explanation of the phenomena and statement of new problems raised by the research, and this can be easily learned. Thank you.